Welcome. Welcome to the session on evolution of computer and processors. Evolution of computer and processors. So how the computers have evolved over the years? It started with Charles Babbage. Charles Babbage actually introduced two machines. One is called as difference engine. The other one is analytical engine. Difference engine and then analytical engines. Both these were never completed actually. They remained as only models or prototypes. They were not completed. But you have to appreciate the vision of Charles Babbage. He imagined what computer would look like. So that's why sometimes Charles Babbage is called as father of the computers. So the computer was never built actually, but it was only a prototype. And it was used for astronomical and mathematical calculations. It was basically a mechanical computer. Difference engine and analytical engine both are actually mechanical computers. Mechanical computers in the sense that they used gears, wheels, levers, not current. Okay, they are not electronic devices. They didn't use transistors, vacuum tubes, etc. But they used gears, wheels, levers. These things you can see in any mechanical device, including your motorbike, gears, wheels, and levers. So first one was a difference engine, then analytical engine, same thing. So it was never completed. It was never completed, but it was also a mechanical computer only. It was also a mechanical computer. So maybe it can be considered as the first general purpose computer, analytical engine. Analytical engine can be considered as the first general purpose computer with memory, arithmetic logic unit, control unit, and supported looping. But still remember, it is not completed. It was not completed. It was only a prototype. It was only a prototype. So initially, Babbage thought that we could use decimal system. But today's computers don't use decimal system. But Charles Babbage's vision was to use the decimal number system. So you have difference engine and analytical engine. Both are mechanical computers and both try to use decimal number system only, but both were not completed. But the prototypes are there still in museums. Next, several analog computers were designed. The first digital computer was Z3. Z3 can be considered as the first digital computer. Okay. First digital computer was Z3. And it was electromechanical computer and it used binary system. That is, everything in the computer is represented in the form of ones and zeros. And it supported what are called as punched films or punched cards on which you can type the cards. Punched cards in the sense that you have to punch something like a typing machine. Something similar to the typing machine has to be used and holes are to be punched onto the card. So if you are successfully able to punch the holes, it becomes the punched card or punched film. The first electronic digital computer is Colossus and it used vacuum tubes and it supported tape-based input. Instead of punched cards, it supported tape-based input. It used vacuum tubes. So the name was Colossus. ENIAC, Electronic Numerical Integrator and Computer, is considered as the first successful digital programmable computer. Electronic Numerical Integrator and Computer is considered the first successful digital programmable computer. Okay, it used these resistors, where different electrical and electronic devices like resistors, capacitors, relays, and mainly vacuum tubes. So vacuum tube is something like your bulb. You might have seen the zero bulb or the volt bulbs in the house, used in the houses, not tube lights. They look similar to the nowadays LED bulbs. So they are vacuum tubes. And the great contribution came in the form of Turing. Turing introduced what is called as universal computing machine or universal Turing machine. It was a revolutionary change. It was a theoretical computer. It was not a computer which is built. Actually, it was a theoretical computer, but the beauty here is you could perform all computations. You could perform different computations using theoretical computer. It just consisted of a tape capable of storing symbols, a set of states, and a read-write head capable of reading and writing symbols. So you have a tape on which you can write the symbols, and the read-write head will be moving, and it can write or read the tape. It can write and read the tape. So we are not getting into the details, but all the computations like addition, subtractions, etc. can be computed using this theoretical computer or Turing machine. The concept of stored program, that means the programs can be stored within the memory, and depending on your requirement, you can change the programs also. That concept of stored program computer was introduced in the form of Manchester Baby. The era of modern computers started in 1947 with the introduction of what are called as transistor and integrated circuit. So transistor was found by mainly this William Shockley, and integrated circuit by Robert Noyce. This revolutionized the computer industry. The current computers are still based on transistors and integrated circuits only. Remember, they were introduced in 1947, but still in 2021-22 also, we are still using transistors and integrated circuits to make the computers. But of course, the density of transistors has increased. So typical processor nowadays, i7 processor consists of 1.8 billion transistors. 1.8 billion transistors. So the one major company that contributed to the development of computers, particularly the processors, is Intel. Intel was founded by Robert Noyce and Gordon Murray. and still it is the major player in the manufacturing of the processors. Evolution of the processors. So the processor started with Intel 4004, which is a 4-bit microprocessor, considered as a 4-bit microprocessor. So in simple terms, you can imagine 4-bit microprocessor or n-bit microprocessor means you can read and write n bits at a time. In simple terms, you can read and write n bits at a time. So first one was the 4-bit microprocessor. Then the series of microprocessors 8008, 8080 and 8085 are considered as 8-bit microprocessors. So these microprocessors still used, not in computers but in the kits, microprocessor kits. 8085 kits are available. So later 16-bit microprocessors came into picture, 8086, 8088, 8086, 286, etc. So if you go to the EC lab and if you want to do the assembly programming, you will be usually using this 8086 based microprocessor kits. So the next series of 32-bit microprocessors are 80386, 80486 and 80586. And the brand name for this 80586, is Pentium. So next series of microprocessors are Intel Core 2, Dual Core, i3, i5, i7 and i9 microprocessors are also available. They are considered as 64-bit microprocessors, and the number of cores also increased. The cores, you can consider them as arithmetic logic units. Within the processors, number of arithmetic logic units are there. You can say they are mini processors also. A core can be considered as a mini processor. So within a processor, you can have number of mini processors, 8 mini processors, 16 mini processors, like that. So I think current technology supports up to 28 cores. This is regarding the evolution of microprocessors. So the current desktop processor is Intel i9 processor, 11th generation processor. So the processors used in servers are little bit different. i7, i9, these are all used in desktop systems or in laptop systems. i9 processor, they are used in desktop systems and laptop systems. If we consider the servers, within the servers, the processors used are come under the brand name Xeon processors. Xeon processors. So these Xeon processors are used in servers, and servers are generally placed in data centers, cloud environments, etc. Okay. Remember, data center is not just a small room. It may be a size of a big factory. It may be a size of a big factory, big university. Okay. Huge number of servers will be there in the data center. Google, Amazon have their own data centers, and they are actually distributed throughout the world. Number of data centers are distributed throughout the world. And also special type of graphics processors are used nowadays called as graphic processors. Whenever you want to work extensively on computer graphics or virtual reality field, or if you are interested in game playing, if you want to design the games, then your computer should have graphic processors. If you want to play real games, you should have a graphic processors. And maybe the current generation of processors may stop here because of the huge amount of heat that is being produced. Because of the density of the transistors has increased, they are generating lot of heat. The people are looking towards other ways of designing the computers. Maybe the processors in future will be designed using the principles of quantum physics and molecular computing. This is regarding the computers and processors. So we have discussed the evolution of computers, how they starting from difference engine, analytical engine, and then digital computers which used vacuum tubes, and then the computers which started using the transistors, and then integrated circuits, and then this current generation of computers, i9 processor computers, and also the server computers where you use what is called as Xeon processors. And we also discussed about processors which started from 4004, which are 4-bit microprocessors, and then we are at the level of now the 64-bit microprocessors, 64-bit processors, 64-bit microprocessors, and also now within the processor you have mini processors. Within the processor you have mini processors. So up to 28 cores are possible with the current technology. That is regarding the evolution of computers and processors. Thank you for watching. Vandanam.